Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Shahira binti Syarul Azizi, and today I'll be presenting my final year project titled Development of Password Web Analyzer supervised by Madam Inurina Ibrahim under the Bachelor of Information Technology in Computer System Security. Let me start with the problem. Password security remains one of the weakest links in cybersecurity. Billions of credentials have been exposed through data breaches worldwide. The issue is that most traditional password tools only rely on rule-based complexity checks like must have one uppercase, one number, and one symbol. But these checks are superficial. A password can pass all these rules and still be very weak or already leaked. So, my project develops a password web analyzer that integrates two things: entropy-based strength measurement and leak password detection through the Have I Been Pwned API. My objectives were to investigate existing tools and identify their limitations, to design and develop the analyzer implementing these two methods, and to evaluate it through functional and security testing. So the scope target is UniKL student through a web-based platform built on Python class. Okay, next for the literature review. For the literature review, I studied several keywords. Bourdieu in 2012 established entropy analysis as a more scientific way to measure password strength compared to rule-based methods. Hunt in 2017 introduced the k-anonymity branch lookup, which became the basis of the HIBP integration. Your and college showed that commercial password meters are inconsistent and don't give real security value. Castelluccia introduced the OMEN augmented tool using adaptive Markov-based estimation, and GUX detailed the privacy k-anonymity protocol. The main gap I found was clear: no existing tool combines entropy scoring and branch detection together with an educational component in one place. So that gap shaped my whole project. Next, we move to the system diagram. For the system diagram, I prepare several UML diagram. The use case and misuse case diagrams show the legitimate user interactions and also the potential attacker threats, each map to a security control like input validation, HTTPS encryption, and rate limitation. The system architecture diagram follows a three-tier design: a presentation layer built with React, an application layer in Python Flask containing the entropy, hashing and HIBP modules, and a data layer that importantly stores no passwords at all, preserving privacy. The activity diagram. So the activity diagram, wait. So the activity diagram then maps the full process flow from password input through entropy calculation and branch checking to the final combined security assessment. So we moving to the prototype development. Okay, the system was built with React on the front end and Python Flask on the back end. When a user enters a password, the entropy is calculated using Shannon's formula, H equal L times log base 2 of R. for breach detection, the system uses the K-anonymity protocol. Only the first 5 characters of the SHA-1 hash are sent to the API, so the actual password is never exposed. As you can see, in the prototype screenshots, the interface shows the entropy score with a color-coded meter, a clear branch warning if the password is compromised, and actionable security recommendation. So next we move to the result and findings. For result, I conduct 2 types of testing. First, functional testing across 4 password profile, weak, medium, special, and strong. All test cases pass. The entropy scores behave logically. ABC scored only 14.1 bits as weak, while a strong random password scored 78.7 bits. The most important finding is password 123. It scores 65.5 bits, which is actually strong. But the breach check found it have been compromised over 1.5 million times. This single result proves exactly why an integrate tool is needed. Entropy alone gives a false sense of security. Breach detection completes the picture. Second, I use security testing. Okay. The security testing using OWASP ZAP. The scan found 4 alerts, 2 medium and 2 low risk, but 0 high or critical vulnerabilities. The findings were development stage configuration issues like missing security headers and wildcard CORS, none related to the core privacy logic. So next we move to the conclusion and recommendation. In the conclusion, the password web analyzer was successfully developed, integrating entropy scoring, HIBP breach detection, and just two only. The system achieved machine learning accuracy above 85% with all functioning all functional and security tests passed. So all the 2 objectives were met. For future enhancements, I recommended developing a mobile application version for wider accessibility, adding a bulk password analysis feature for organizational use, and integrating with the University student portal for password health monitoring. So next for the commercialization. Finally, on commercialization, the password web analyzer can be offered as a software as a service, SaaS, product for university and organization. Since it's built entirely on open source and free tier tools, the cost to scale is low. It can serve as a free awareness tool for university onboarding, follow a freemium model where business pay for bulk scanning and reporting, and even be what level for SMEs that can't afford commercial auditing software. The machine learning layer adds value, giving it an edge over single factor competitors. That concludes my presentation. So we're moving to the wait. We're moving to the demonstration. So basically, this is my project. So we type I type ABC 1, 2, 3. So we analyze the password security. We enter wait for it to analyze. It take longer time to process. Okay, so this is the final. So it shows the entropy scoring is 31.0 bits. So the strength level is medium. And it say the password is branch. So it found like graph 990 and 806 times in branch database. So it say do not use this password because the password is leaked. And then last, it gives a security alert recommendation. So that's all from me. Thank you.